everyone. This is another video of OOPS, and in this video we are going to understand some more concepts of object-oriented programming. Alright, so now in last video we saw how to call the properties of a particular class in the main function when they are marked as public. Now we are going to understand how to call these functions in the main functions. So we don't have to do anything, we just have to type the name of the object and call the function, and we have to type the name of the object and call the function. In order to for it to be in next line, we have to add a line over here, and as we can see we are able to call the functions. Now okay, so what if we want to access anything that is marked private over here in the main function? For example, we have a weight, we have weight of a particular animal which is marked as private. Now we have weight of a particular animal which is marked as private. How are we going to access that weight into this main function? So in order to access the weight which is marked private, we are going to use getters and setters. What is the purpose of getters and setters? They are used to access and modify private fields of a class. As we can see, this field has been marked as private. Getters and setters can be used in order to access the private members of the class. And let's see what is the difference between getter and setter. So basically, getter is used to get a value of particular field. For example, if you want to get the value of weight, and setters is used to set the value of weight. For example, weight is currently 15 or weight is nothing, it has a garbage value over here. We have to set the weight to 30. Then we are gonna make the use of setter. Let's create getter and setter once. So in order to create getter, we are going to create int get weight, which will be passed a value. It will not be passed a value, and it will be a void function. It'll not be passed a value, but it will be an integer function which will return us the weight, right? Which will access this and return us the weight. And in order to get set the weight, we'll have a void function set weight, which will be passed the value which we want to set, and the value of weight would be set to w, right? W, which value we passed, the value of weight will be set to w. Now there's a catch over here. Even though this property is private, the functions over here should be public. In order to access getter and setter, the getter and setter function should be public. Now let's call these functions. Okay, doggo dot get weight, but in order to get weight we have to set weight first of all. So we'll set the weight to 15, right? Let's go ahead and run this. So okay, we are not printing this, we should print the value of weight, right? So let's go ahead and see. So okay, we have not added a line. Yeah, so we have set the weight to 15 and we have returned the weight 15. Even though this was marked as private, by using getter and setter we have returned the value of weight, right? Okay, all right. So let's see. Now we have seen static memory allocation. Now we are going to see dynamic memory allocation. Okay, how are we going to create a dynamic memory? For example, we are done with dogs and we have a new animal which is named Catty, right? We have a new animal cat which is named Catty, which is a new object. Let's just name it cat, which is new animal. Now here we have created an object named cat using dynamic memory. In static memory, we just had the name of class and name of object. Over here we have name of class, star, name of object, new animal. What does the star mean? It means a pointer, because this value is going to store the address of this particular animal. That's why we have a star over here. Now let's set some properties of this cat. Let's set the age of cat to 5. Let's set the what do we have over here? Name of cat to catty, right? So we have age and we have name, right? Okay, so now over here inside this cat object there is address of the new animal, right? Now we do not have to print the address of this cat animal, right? We do not have to print object address of this cat animal. Over here what we are doing is we are setting the age of address of this cat, which is wrong. We cannot set the age of address. We have to set age of this particular object. So we'll use dereference over here, as an address is stored inside the pointer. In order to access the value of that particular pointer, the value which is kept on that particular address, we have to use dereference pointer. Now let's see what is the right method to do that. So what we'll do is cat, this is a dereference pointer, and age of this value would be 5, and again a dereference pointer, and name of this particular cat would be catty, right? Let's just go ahead and erase this, and let's see if are we going to we can print this or not. So yeah, over here we can print 5. We have just not added a line, that's why it's not coming in next line. But yeah, we are able to print the age of this cat. Now we do not need to write this ugly code in order to access the value of this cat. We can just use this is alternate to that ugly code. We can just use this operator, right? We can just use this arrow over here, and this is a pointer to the value of that particular address. We can just set this like this. We can just set this like XYZ, and we can go ahead and print this. We should get 18. We are getting error, semicolon is missing. Let's go ahead and run this. We are getting 18, right? So yeah, we are able to set the value. We are able to use a dynamic allocation. Now there is a really nice function of dynamic memory allocation, that we can delete this particular object. We can just go ahead over here and write delete cat, and we can use the deallocation over here, right? So yeah, now all right, now over here I did something really nice, which maybe some of you guys might have noticed, that over here we have passed a value w. We have not passed a value weight, right? What if there is a particular weight over here and we just have to set the weight to this particular weight? Then would it be weight is equal to weight? Would it be weight is equal to weight? No, right? What would we do if we have the the parameter of a function same as the data member which is defined in this particular class, which is marked as private? What are we going to do in this situation? We over here we can make use of this operator. What we can do is this the weight of this particular value should be the value passed over here, right? The weight of this particular value should be value passed over here. So over here what we are doing is we are creating a pointer to object. We are creating a pointer to object which we have defined in the class. We are creating a pointer to object which we have defined over here in the class, right? So as it is a pointer, we are using this arrow, right? As it is a pointer, we are using this arrow, right? Okay, now let's see what is a constructor. Let's see what is dynamic memory. We've already seen it. Let's see some theory. It is used for memory allocation, right? In object-oriented programming, memory can be dynamically allocated. What is this doing under the hood? It is using heap storage, right? Objects are often stored in heap, a region of memory used for dynamic memory allocation, right? Now let's see what are constructors. Now constructors are nothing but basically used for object creation, right? So basically constructor is nothing but used for object creation. What if we have to initialize a particular object? What if we have to ourselves initialize a particular object? It can be dog, it can be cat. What if we have to do that? We are going to make use of constructor. Constructor has no return type, right? Constructor has no return type. And the name of constructor is same as name of class. The name of constructor is same as the name of class, and it is used for initializing a particular object. It is used for initializing a particular object, right? All right. So let's see how constructors are made. For example, inside the animal class, as I told you earlier that the name of the constructor should be same as the name of class. So inside the animal class, what if we call a constructor named animal which returns nothing? As constructor returns nothing, it will return nothing. Well, let's just go ahead and print this called over here. We'll just see if this constructor is being called or not, right? Now we have created an object over here. Let's go ahead and run this. Called is getting printed, right? Called is getting printed. Why it is getting printed? Why is constructor being called? Because whenever we create an object, okay, I can go ahead and increase the font's value. Let's keep it as 17, right? So whenever we create an object, constructor is called. Constructor of the particular class. Whenever we create an object of a particular class, constructor of that particular class is called, right, by default. Now it is called in both static and dynamic memory. It is called in both static and dynamic memory allocation. Now what if we would not have made a constructor over here? Earlier we did not have any constructor, but still some things were getting printed, right? So by default a constructor is getting called. Under the hood, by default there is an animal constructor over here which is being called, right? Now what if we have written over here, but we have defined our constructor over here? If we write our own constructor, then the constructor which was getting called gets overwritten. gets overwritten, right? The constructor which we have written will be called, and the constructor which was being called earlier will get overwritten. Now in this constructor we can do other properties also. We can set the weight, we can set the age. Let's set the weight to 0 and let's set the age to 0. Now I have not defined weight till yet. I can do this, right? We have set the weight to 0, we have set the age to 0. We can do this inside a constructor. Another thing which we can do is we can have a parameterized constructor. Right? In parameterized constructor we can have parameters in the value being passed in the constructor. For example, age, we're passing over here age, we're passing the age over here, right? And we can set the age to age. Now what will do is it will create a pointer to the object which we have inside the class, to the property which we have inside the class, right? Now let's see which constructor is being called. Parameterized constructor called, right? Let's see which of these constructor is being called over here, right? Let's just print constructor called and parameterized constructor called. Now let's go ahead and run this. All right, now this is not being called. Why are we not able to call this parameterized constructor? Because we have not passed the value of age. We have not passed the value of age when we have created an object. That's why this parameterized constructor will not get called, right? What if we pass the value of age? What if we pass the value of age over here? Then that constructor can get called, right? If we pass the value of age over here, we have it private over there, but yeah, if we have it public, then yeah, we can see parameterized constructor called, right? Now let's go ahead and see if we can have multiple parameters over there, right? Let's create a constructor which will have multiple parameters. It has weight, it has age, and it has weight, right? Let's set the age to age and let's set the weight to weight, right? Now let's go ahead and pass the value of age and weight over here. We have passed age as 10, weight as 15. Let's call this now. Okay, first of all, how will we know that this is getting called? We'll just say second constructor called. Okay, so over here we can see that second constructor is being called. It will go ahead and find the constructor based on the values, based on the parameters that is being passed in the creation of object. Now let's see what is copy constructor. It is a very important concept, which is copy constructor. Let's see what is copy constructor. Now in main function we have two ways to create an object, right? In main function we have two ways to copy an object. For example, we have to copy this object doggo, right? Let's just go ahead and comment this code out now. Okay, two ways to copy an object. Let's study about copying the object. For example, we have an animal named X, but this animal we have to copy in A, right? And we have an animal y, but this animal should be same as b, right? We have to create a new animal x which should be same as a. We have to create a new animal y which should be same as b, right? What will happen over here? Over here, what will happen is we'll make a copy constructor. We are going, let's go ahead and remove this public because everything is public. We'll go ahead and create a copy constructor. Now in copy constructor, what is happening? We have the name of class, and another object which we have to copy, right? Let's go ahead and put the same age as the age of another object, right? The age of first object would be same as the age of second object because we are copying everything, right? Each and every state, property, each and every behavior will get copied. So let's set the age as same. Let's set the same age. Let's set the same weight, right? And let's just go ahead and print that we are inside copy constructor, right? Now there is a problem over here, right? There is a problem over here. This constructor, this is a copy constructor. This copy constructor will not get called. Why? Because this value has been passed by value. This particular value over here has been passed by value, but this value should be passed by reference, right? When we pass anything by value, it will create a new memory which will not have any data, just an addresses and an empty, the data would be empty, just addresses would be there of the same size. But if we pass this by reference and if we actually have these objects over here, then it will work, right? By reference. So in order to use copy constructor, we have to pass the value of the other object by reference, not by value. What is the use of copy constructor? Use cases. So the use of copy constructor is by default the constructors that we have, they do a shallow copy, right? By default the constructors that we have will do a shallow copy. What if we have to do a deep copy? Shallow copy means we are not copying everything. The object is not being copied properly. But what if we have to do a deep copy? Everything should be same. Then we need a copy constructor. Right? Now let's go ahead and try this out. For example, we have an animal A. Right? We have age of this animal as something 20. We have to set weight of this animal. Even though we have weight as public, we will just go ahead and run the setter. We'll set the weight of the animal as 15, and we'll set the name of animal as dog. Right? Now we have an animal A and we have defined the properties of that particular animal. Now if we want to print the function inside the class, print this function print these values inside the class. What we can do is we can create a value, we can create a function as print, and we can print the values of this pointer, the pointer that we have defined over here. We can print the age, we can print the weight, we can print the name, right? We can print the age, we can print the name, we can print the weight. Now we do not have to write print statements over here. We can just simply define a print function inside the class in order to print the values, right? But we have to call the function print in the main function, right? We have to call the function print in the main function, right? Right, so the values are getting printed. Okay, so first of all, we are not having any spaces. We can have spaces over here. Let's have one endl statement, and yeah, I think that's it. So yeah, as we can see, everything is getting printed from inside the class, right? Now what we can do is let's create a copy of this a animal. Let's go ahead and create a copy of this animal. So animal A will be B, right? Let's create a copy of this animal. A is equal to B. Let's do a dot print align, and let's do b dot print. Let's print everything of this object and print everything of this object. Let's see what is getting printed. Okay, so redeclaration of animal A. Oh sorry, okay, over here we are creating an animal B which should be equal to A, right? We are creating new animal B which should be equal to A. So let's go ahead and run this. Okay, first of all, it's telling that we are inside the copy constructor. It is printing everything of A but not of B. It is printing everything of A but not of B, right? Okay, we have not printed name. We have not printed name over here. That's why it is not printing the name of B element. But if we printed the name of the object is name. If we print it name is doggo, okay, obj dot name, right? We have to set the name of that particular function, so obj name. So as we can see, a deep copy has been created. Everything that A has, everything like age, weight and name, the same things are there in the values of B. Now we have studied constructors. What if we have to delete everything? What if we don't need an object anymore and we have to delete it? We have to create a destructor for that. How are we going to create a destructor? Let's see. In order to create a destructor, we'll go inside the class. We'll use this curly arrow. We'll use this curly hyphen, we can say. We'll use this curly hyphen, which is over the tab key in your keyboard, and animal. We'll write the name of class we have to delete, and we'll just print I am inside the destructor. We'll just print I am inside destructor, and from this and from this the whole class will get deleted, the whole class will get destructed, a whole class will get deleted. As we can see, we are able to print I am inside destructor. Why is it printing twice? Because we have two objects over here, we have A and B, right? But destructors are only there in dynamic memory allocation. They are only there in dynamic memory allocation. In static, destructor gets called by themselves. In static, we do not have to create a destructor like this. It will go ahead and get called by themselves. And in dynamic, we have to create a destructor, right? In dynamic, if we create an object, we have to create a destructor. For example, we have created an animal C, which is a new animal. It is a dynamic memory allocation, right? We can see it is a dynamic memory allocation. Let's go ahead and set the age of this as 1. Now in order to delete this, we have to use delete C, and it will delete the animal we have created, right? I think that's all for this video. In next video, we are going to look at 4 pillars of OOPS, right? Thank you so much. Bye bye.